Hello everyone and welcome to Introduction to Logic. This is Module 1 and this week we really want to just focus on the question, what is logic? And we also want to look at some of the most significant developments in the history of this discipline that has come to be known as the study of logic, a subdiscipline of philosophy. We should also consider then, what is philosophy? But let us begin, just for fun, with a question. Suppose Epimenides of Crete comes up to you and says, "All Cretans are liars." Is this statement true? Now, on the one hand, Epimenides is relaying this information to us quite matter-of-factly. What reason do we not have to believe him? But then you realize that Epimenides is a Cretan. And according to his own statement, all Cretans are liars. So all includes a class that has every Cretan in it, including Epimenides. So, if we are to take his statement as true, then Epimenides himself must also be a liar. Now, this would suggest that the statement is not true, right? All Cretans are liars was stated by a liar, therefore we have no reason to accept it. So it may not be the case that all Cretans are liars. But notice, if we reject it in this way, assuming that all Cretans are liars, including Epimenides, and therefore we should not take this claim seriously, we have first assumed that we should take it seriously. For we based our rejection of Epimenides' claim on the assumption that all Cretans are in fact liars. So it is a bit of a paradox. It may be true that all Cretans are liars, yet we have no real reason for accepting that as truth unless it is given to us from someone who is not a Cretan. Yet, if we are given this statement from a Cretan, we are in a bit of a dilemma, because according to the statement, we have no reason to believe the Cretan, and yet we have to believe the statement in order to make the assumption that we should not believe the Cretan who utters the statement. Welcome to the joys and pains of logic. Let's begin now with a clarification of our terminology. Logic is a subdiscipline of philosophy, but what is philosophy? And then what is logic? And why are these important? Do they mean anything for you as a student? Or is philosophy just something for some stuffy old professor sitting in a leather chair smoking a pipe? No, coming from the Greek word having to do with love, philo, as a prefix, involves loving something, just as miso, as a prefix, involves hatred of something. And Sophia comes from the Greek meaning wisdom. So a philosophos is a lover of wisdom, or one who loves wisdom. That is, one who has a passion for seeking understanding. So philosophy is a quest for understanding, a journey toward enlightenment, a passion for truth. Now, logos relates more directly to the concept of word, but it means both word and reason, because one cannot speak, even think, reasonably without language of some sort on some level. And one cannot formulate language intelligibly without reason, a rational ordering process. They are fundamentally intertwined. So logic refers to the rational discourse that relies on inductive and deductive methods of reasoning, and it is a study of principles and criteria of valid inferences and demonstration. How can we so formulate our ideas so that one idea moves us on to the next, and two ideas taken together can move us convincingly to a conclusion? Throughout this course, we will study many different approaches to logic. formal and informal reasoning, deduction, induction. There's also abduction, existentialism, and other approaches. But we will focus especially on categorical logic, propositional logic, and deductive reasoning. Now, propositional logic can also be called sentential logic because it is a method of inference which formally applies logic to the analysis of a series of propositions or sentences. For example, if I have reason to believe that it is the case that if S is true, then X is true, and if I have reason to believe that X is equal to Y and Y is equal to Z, and if I have reason to believe that S is in fact the case, then I can quickly conclude logically that X is in fact the case, and therefore Z is in fact the case. For premise 1 in this argument tells me if S is true, then X is true, and premise 4 tells me S is true. Therefore, we know X must be true. And if X is true, and we know from premises 2 and 3 that X is equal to Y and Y is equal to Z, then we know that Z is the case. This is propositional logic using deductive reasoning. Now, as we are part of the Western European tradition and our approach to logic is influenced by that, we need to consider the significance and impact of ancient Greece upon the history of Western thought. Very little of our Western history has not been influenced by the Greeks. They influenced disciplinary approaches to philosophy, science, political thought and democracy, the arts, mathematics, and more. Now, mathematics had been around long before the Greeks, but the Greek love for rational demonstration, for proofs, logical proofs, revolutionized Western mathematics. And this really goes back to Pythagoras. Now, after Pythagoras, who so far as we know was the first to call himself a lover of wisdom, there were several Greek thinkers who contributed significantly to the development of rational logical thought and the articulation of arguments. And they stressed that we need to be willing to follow one idea to the next, and however uncomfortable it may be, we should be willing to go wherever the argument leads. Always be willing to follow the arguments to their logical conclusions. The most influential and noteworthy philosophers of ancient Greece were Socrates, Plato, and Aristotle. They are living at what we call the Golden Age of Athens. And then following Aristotle, we have the next significant figure in mathematics following Pythagoras, and that was Euclid. So philosophy began with questions about the elemental nature of reality. And it was taken as a given that there exists some underlying order, a harmonic order which permeates the cosmos. And order can be expressed in number. Thus, for the Pythagoreans, everything is number or comes down to number at some level. The Pythagoreans were philosophers, musicians, and mystics, religious mystics, with a particular passion for geometry. Again, Pythagoras was the first to actually call himself a philosopher, and his developments in geometry had immeasurable impact on the history of Western thought. You yourself are probably familiar with the Pythagorean theorem. Also, the musical scale owes much to some of the discoveries of Pythagoras. Now, Pythagoras lived in the 6th century BC. About a century later, in the 5th century, we meet Socrates. Socrates was an influential philosopher who challenged many confident people to think more carefully about their terms and assertions and to work harder to justify the claims they were making. He exemplified the power of beginning with a clear definition or idea and then using a technique called reductio ad absurdum in order to show that the definition or idea leads to an absurd conclusion. And so, if that's the case, one should go back and begin again in order to reason more clearly. Now, the reductio ad absurdum, or the reductio as we may call it, is a technique that you will need to learn in this course. First, assuming the opposite of what you think is the case, you work to demonstrate that this alternative approach leads to a contradiction. So if somebody asserts that P is true, and we have reason to think that is doubtful, we might actually begin with that assumption. Okay, suppose P is true. And then we work our way logically to the conclusion P is false. Now, if that's the case, if our logic is good, and yet our argument can contain both premises that P is true and P is false, then there's a problem. We have found a contradiction. And so the initial assumption P is true should be refuted. We will learn more about this in a later module. You do not necessarily need to know how it works now, but you do need to be able to identify basically what it is and associate it with Socrates and the Socratic method. Now, the Socratic method in general usually refers to a method of inquiry or using questions in creative and powerful ways. But the reason that Socrates used questions in the ways that he did was to expose these contradictions, so that rather than just coming along and saying, here's all the places you are wrong, all the places where your logic contradicts itself, he came alongside the person who asserted P is the case, and he used questions to help them think through and find the logical processes for themselves to realize that that assertion leads to contradiction. And so we need to go back to the beginning and try to work through the logic again. Suppose, for example, that someone says there is no truth. Let this be P. This is a statement. It's a statement about the world, a proposition. And all statements are either true or false. So let us assume that the statement is correct because it is asserted as true. P is a statement that is either true or false. Yet, according to P, we should conclude that it is false because the statement says that there are no truths. So P is false, since P is a statement. This would mean that P is both true and false. But this cannot be. It is a logical contradiction. Thus, we should reject the initial assertion, P, that there is no truth. And we could easily apply the Socratic method of questioning to expose the contradiction whenever someone says there is no truth by simply asking, is that statement true? Next comes Plato, loyal follower of Socrates, and an extremely important philosopher in the history of the Western world. He established the first institution of higher learning in Western history, called the Academy, which had the inscription above the doorway, "Let none ignorant of geometry enter here," again signaling back to Pythagoras the significance of geometry and mathematics in providing key insights into the nature of logic and the world. Now, we are not going to focus as much on Plato in this course as we would in my ethics course or intro to philosophy course. However, I do want you to understand his significance. It has been said that all of Western history is just a series of footnotes to Plato. That is, everyone who comes after him is either expanding on what he contributed or said, or else they are trying to offer some sort of counterpoint or disagreement. But the dialogue, the great conversation of Western history, keeps going back to many of the ideas that Plato set on the table. We are going to focus, however, on Plato's most famous student, Aristotle. Aristotle studied and even taught at Plato's Academy for a time, and then left and eventually came back to Athens and developed his own institution called the Lyceum. Aristotle is significant for a number of reasons. For one, he developed the field of study that would come to be known as biology. Interested in marine life in his surrounding area, he began to study nature and categorize many of his findings. And his approach to categorization in both science, which was just called natural philosophy at the time, and logic are extremely important in Western history. At the Lyceum, he would spend the mornings tutoring his paying pupils, and the latter half of the day he would spend offering free public lectures. His approach to teaching was rather unique. He enjoyed walking through the gardens there, and so his students would walk and talk with him, and this is how they discussed their ideas and sharpened their minds upon one another. And this unique conversational approach to education is why his students came to be known as peripatetics. A peripatetic is one who travels from place to place. In addition to philosophy of nature, natural philosophy, or what would eventually come to be known as science, Aristotle contributed significantly to other areas of philosophy, including ethics and, for our purposes, logic. He is actually considered the father of Western logic, and his work profoundly influenced both Christian and Islamic thought and the rest of Western history. Importantly, he observed that all reasoning begins with certain basic certain truths that are taken as given, and these he called first principles. Now, minimally, anytime we reason or have a conversation, we presume at least three basic foundational principles: the law of identity, the law of non-contradiction, and the law of excluded middle. According to the law of identity, A is A, or A equals A. When we speak of a thing, we must understand that we speak of a particular thing, a particular object or definition, and that when we speak of that thing, we understand we are not speaking of any other thing. Thus, we can speak of x plus y, understanding that x represents one thing and is not the same as y, and y represents one thing that is not the same as x. And we understand that plus represents something that is not x or y. All of our experience and understanding in the world through experience is based on recognizing what a thing is and what it is not, or that a thing is and that it is not, or even spatially where a thing is and where it is not. When I reach for my phone, I reach for the thing, and I understand the thing to be in a certain place because I am also able to recognize all of the space that is not the thing. So our most basic forms of reasoning have to presume that we can identify things, that we can say of something A equals A. We understand that X equals X and Y equals Y. Because we can recognize the thing, we can also recognize what is not the thing. Or because I can recognize where my phone is, I can also recognize where it is not. So to understand the law of identity is also to understand the law of non-contradiction, that A is not the same thing as not A. A does not equal not A in the same way at the same time. So something cannot be both X and not X at the same time and in the same way. Even if a given context brings with it a spectrum of shades of gray, which can shape our terms and affect our understanding, there is nevertheless, at bottom, a necessarily binary nature to truth. All truth statements are either true or false, and something cannot be both true and false in the same way at the same time. Now, why do I make that last distinction, in the same way at the same time? This is because we can manipulate terms. We can modify our language. Some guitarists, for example, call the guitar an axe, especially in rock guitar, my axe. And so in this case, we have two things, an axe that we use to chop a tree and an axe that we use to play music. So the axe, if by which you mean something to chop a tree, is not the same as an axe if you mean something to play the guitar. And so it could be said that this is an axe and is not an axe if we're speaking of a guitar. In one sense, it is an axe. In another sense, it is not. However, once we clarify our terminology and we understand that we are speaking about something in a particular way, then we cannot say it is both and. So if we clarify by axe, I mean a guitar and not something to chop a tree, then I cannot point to a guitar and say this is an axe and is not an axe, because we have clarified that by axe we mean the thing on which we play music. So A cannot be both A and not A at the same time in the same way, or something cannot be both true and false. We understand this. Again, it's basic to our experience. We understand that something is or something is not. When I grab my phone, I recognize a sort of being or existence where something exists, and I understand that it is not the same as all the space where I see no existing thing. Now, because our basic reasoning at the foundational level, from being minds experiencing a world, understands the law of identity and the law of non-contradiction, we necessarily also understand the law of excluded middle. Because there is, at bottom, a binary nature to truth, because A equals A, and it is not the case that A equals not A, then clearly what follows is that either A or not A is the case. This either but not both is a fundamental principle, a sort of axiom or basic truth that we understand from our experience. So there are basic and obvious truths which we all must assume or presume before we even formulate an intelligible statement. Thus, they serve as foundational assumptions or first principles or basic truths that we call axioms, upon which all rational claims are built. Think about it. Logic and science both begin with certain axioms. From these, we set forth propositions, that is, statements about the way the world is and is not. Science assumes prior supposedly established ideas as a given, as fact. Even if such ideas may be challenged later in the future, they have to begin by supposing that the prior conclusions of scientific inquiry and investigation are sound. And then they proceed and build new studies and theories upon these postulates. Now, this was quite influential on a guy named Euclid, influenced by Aristotle's deductive method, and especially this idea of first principles, the basic assumption which cannot be derived from other propositions. Euclid combined and systematized many of the geometrical beliefs of his day and presented them within a logical framework with deductive proofs in his work, Elements. Euclid's Elements begins with a series of definitions, axioms, and common notions in order to then build a system of geometrical proofs. For example, things which are equal to the same thing are equal to one another. We must first start with that axiom. Or an axiom like all radii within a given circle are equal to one another. Beginning with axioms like this, Euclid is able to demonstrate things like it is possible to construct an equilateral triangle, as long as we understand that all radii of a given circle are equal to all radii within that circle. He is also able to prove Pythagoras' famous theorem that given a certain triangle, the square of A plus the square of B is equal to the square of C, or the hypotenuse. Now, Euclid's work was so highly influential in the history of Western thought that it is the second most published work in history, second only to the Bible. Now, throughout the Middle Ages, we have a lot of developments in philosophy of nature, philosophy of religion, and other areas of philosophy. And the developments in logic are primarily influenced by Aristotelian thought. It's not really until the other side of the Enlightenment that we begin to see new developments in the history of logic. So skipping ahead to the Enlightenment, we begin to see some new developments in logic, and we also start to see some of the older ideas used in new ways. Going back to the idea of geometry as so foundational to our understanding, Immanuel Kant, a philosopher of the 1700s, observes that geometric truths are known only by reason, while the empirical sciences show us that much of our understanding comes from sense-based experience. Kant is pointing out that there are some things that we know, and they do not come from our sensory data. The axiomatic language of self-evident truths would go on to influence many of our ideas concerning natural rights. Now, natural law theory is tethered to the Judeo-Christian tradition and observes that all human beings created in the image of their maker bear a special mark, and that special mark gives them a special dignity, and with it a certain sense of basic due justice and rights. And any real and robust sense of ethics and justice must assume as an axiom that we owe certain things to one another, or that human beings have certain basic rights. Now, while some claim that slavery was a sovereign right to be decided by the people of each state in the United States, Abraham Lincoln, appealing to Euclid, challenged, if Judge Douglas, with whom he was arguing, will demonstrate the right of any one man to make a slave of another, without any right in that other, or anyone else to object. If he will demonstrate it as Euclid demonstrated his propositions clearly, then there is no objection. Of course, what he is implying is that if it cannot be axiomatically demonstrated that slavery is a sovereign right, then there is no real reason for believing slavery to be justified or justifiable. In fact, if we take it as axiomatic that human beings have any sort of intrinsic right, then all human beings have a certain basic sense of dignity, and so all human beings have a sense of responsibility, or they owe it to one another to respect this basic intrinsic dignity in each person. Thus, slavery is in fact unjust. So notice, even when we don't draw attention to it, how foundational this idea of axiomatic truth is in our case building. The influence of Aristotelian first principles and Euclidean geometry can also be seen in the Enlightenment philosopher René Descartes. Inspired by Euclid and skeptical of contemporary scientific assumptions, Descartes suspected that there are many things that we assume to be the case, yet which cannot really be known as clear and distinct. So he decided to doubt everything he knew, to rid himself of all axioms, and then to analyze each of his previously held axioms, accepting only those which he could say were truly clear and distinct, in order to then begin with what he could know for a fact and argue his way through rational demonstration to what else could be concluded from these axioms. He concluded that the only foundational axiom of which I as a thinking thing can really be certain is that I exist and I am a thinking thing. That's it. Everything else that we know or believe ourselves to know is built upon these axioms. I think, therefore I am. Our transition in the direction of modern logic really begins with Thomas Hobbes. Although, as we've seen, logic has a rich and long history in association with mathematics, Thomas Hobbes suspected that logic is actually reducible to mathematical expressions, such as addition and subtraction. Later, in the 1700s, Gottfried Wilhelm Leibniz suggested that logic can be reduced to symbolic calculus. And reducing the reasoning process to a series of symbolic calculations can help us to sidestep some of the problems that we run into in our language involving differences of opinion by making our terms as clear as possible. Complex ideas are really just simpler ideas put together. Ideas like conjunction, two things together, is the same as saying X and Y are both the case. Or disjunction, that two things are not both true, is like saying X is the case or Y is the case. And negation, using negative language, is like saying something is not the case. This begins what is called the embryonic period of modern logic. The modern era, by the way, refers to the 1600s through the 1900s. Modern logic takes the basic form of calculus, focusing more upon the order or the form of symbolic operations rather than the meaning of the symbols per se. If we can take all the language or the meaning and translate them into mathematical symbols, then we can just do the math and find out whether our logic is valid. The real change comes in the 1800s, and this is what we call the Algebraic period. Here, logic really takes on its modern form. And a lot of this goes back to a guy named George Boole, who showed that algebraic formulas are actually really effective in demonstrating the logical processes. For example, x plus y equals z. If we have reason to believe x plus y, then we conclude Z. Let X be the suspect is a man. Let Y be the same as the suspect has never been married. And let Z be the suspect is a bachelor. If it is the case that the suspect is a man, and if it is the case that the suspect has never been married, then it is the case that the suspect is a bachelor. Or, view it the other way around, if it's the case that the suspect is a bachelor, then it is the case that the suspect is a man and the suspect has never been married. So Z equals X and Y, or X and Y is equal to Z. Augustus de Morgan is another important figure here, and he establishes what we have come to call De Morgan's laws. Now, you will become more acquainted with these laws in a later module. For now, we're just focusing on the historical contributions. But De Morgan's laws essentially notice that we can look at something from two different ways, and sometimes it's helpful to think about it from a different perspective. There's two primary laws here. We could say that it's not the case that A or B is true. Let's break that down. Now first you should recognize that or implies either. So to say A or B is really to say either A or B. So it could be the case that either A or B. For example, either she is a first-generation college student or she does not go to college. One of those is true, is what we're asserting when we say A or B. Now, to say not A or B, we're saying that's not the case. It's not the case that either this or that is true. What if she does go to college, but she's not a first-generation college student? That either or doesn't fit. So we could say not A or B, meaning it's not the case that either A is true or B is true. But the more to notice is that we could also say it's not the case that A is true and it's not the case that B is true. So there's kind of a shifting that can happen with our and or language when we use negation or negative phrasing. Not either A or B is the same as saying not A and not B. And this works the other way as well. If we have a statement A is true and B is true, which means they both have to be true, we can negate that and say not A and B. And De Morgan observes that this is actually the same as saying not A or not B. For example, if it is not the case that I ate a banana and an apple for breakfast, then we can safely conclude that either it is not the case that I ate a banana, or it is not the case that I ate an apple. It may be the case that I ate neither, but we cannot safely and logically make that assertion. Another contribution comes from John Venn, who lived in the late 1800s and died in the early 1900s. John Venn introduced diagrams for helping us to visualize categorical concepts such as all x are y, some x are y, no x are y, and some x are not y. This was also the time when Charles Dodgson lived. Dodgson was an author and mathematician better known by his pen name Lewis Carroll and his classic books Alice in Wonderland and Alice Through the Looking Glass. Dodgson was particularly influenced by Euclidean geometry, and he was interested in logic and especially paradox and fallacies, which show up a lot in his Alice tales. The next stage in modern logic is called the Logistic period. The period begins with Gottlob Frege, who is considered the father of analytic philosophy. Frege argued that logic and arithmetic are identical. Taking a noticeable step forward in the formal rigor of symbolic logic, Frege was particularly interested in picking apart statements like every A is B. Specifically, what exactly is meant by saying something like, there exists a thing, an X, such that if X describes A and if X describes B, then A is equal to B. He wrote it like this: for all X, if X is an A, then X is a B. This greatly influenced Bertrand Russell, who is considered one of the most famous logicians of the 20th century. Russell scrutinized language in order to expose even further issues with ambiguity. If every meaningful statement is either true or false, then the negation of that statement, to deny it, should deal effectively with any question as to the existence of the thing in question. For example, if I say there is a unicorn in my garden, and you deny this, you have implied there is no such unicorn. So if I say there is a unicorn in my garden, and you say, no, that's false, what is implied is that just the opposite is true. So if it's false that there is a unicorn in my garden, then this means it is not the case that there is a unicorn in my garden. But here we find a problem. Suppose I say, the unicorn in my garden is blue, and you reply, that's not true, that's false. In this case, what have you really said? The negation of the statement, the unicorn in my garden is blue, to say that is false just means it's not the case that the unicorn in my garden is blue. So all you've really denied is the assertion that my unicorn is blue. Your language has not allowed anything in it for an ability to deny the very existence of such a creature. So Russell locked onto this and he said there are problems with the way that we formulate our language. And if we could find ways to express them so clearly in our symbolic representations that we can get rid of all of that potential for ambiguity, then we will always be able to get clearly to the answers we need and not get lost in meaningless talk. Russell is arguably most famous for dealing with a problem concerning our talk of the King of France, who is bald. Russell observes several areas of potential confusion. For example, which king do you mean? France has had several kings. So you might say, the present king. Well, that's not really helpful, since the present could mean currently alive, or it could mean present with us. Perhaps there are two kings, and there's one present with us today and one elsewhere in the world. Actually, he observes, that's neither here nor there because the problem remains. The greater problem is the fact that there is no current King of France. Much like with the unicorn, if you say the present King of France is bald and I say that's false, I have only said that the present King of France is not bald. So how can we deal symbolically with the fact that there is no King of France? Recall that all propositions come in a basic form of true or false, so we need to find some way to get our language into a form or formulation that will allow us to say that there does exist or does not exist such a person that is the King of France and is bald. Now, Russell's solution is to come up with a symbolic expression that can communicate essentially this. There exists an X such that X is the King of France, and for any other Y that might exist, if Y is also the King of France, then we're talking about the same thing. X is equal to Y. And also X is bald. Now this is a mouthful, but notice what he's done. He's put on one side of our equation, there exists an X such that. So X equals, and then on the other side of the equation, he's put all the other stuff. So now, to deny it is to say X does not equal all that stuff. This works. Back to the example with the unicorn in my garden. If I say the unicorn in my garden is blue and you deny that, all you've said is the unicorn is not blue. But if I clarify and reformulate my language to say there exists an X such that X is a unicorn and X is standing in my garden and X is blue. Now everything hangs upon the there exists an X. X equals all that stuff. So to deny it is to say there does not exist such an X. Another innovation in the history of logic that came along in the 20th century was the truth table. We will use the truth tables later in this course. For any compound statement, that is, a statement containing a combination of variables, a truth table is a diagram that is able to determine the truth value of every possible combination. It is thus able to determine whether the argument is valid or not. This innovation was invented in the mid-20th century by Ludwig Wittgenstein, a philosopher who profoundly influenced the course of philosophical history in the 20th century. One of the most striking things about Wittgenstein is that he changed his mind halfway through his life. In the earlier part of his life, he argued for one position, and then he changed his mind later in his life and argued against all he had previously argued. This is striking and honest because it takes a brave and open mind to say, Everything I used to think, everything I thought I knew was wrong. So let me start over and try again and see where my propositions take me. That's exactly the sort of honest inquiry that Socrates championed, and the spirit of following an argument to its logical conclusions that the ancient Greeks encouraged. The 20th century saw other developments in mathematical logic, which laid the foundation for developments in computer science and artificial intelligence. Analytic philosophy and mathematics continue to influence one another throughout the century and on into the 21st. Most notably, this can be seen when applying logic to concepts of time and modality, speaking, for example, of possibility and necessity, or possible worlds. Consider all of the recent cinematic and comic book interest in exploring multiverses. This concludes our survey of the historical development of logic as a subdiscipline of philosophy and some of the most historically significant points along that journey.